In this video, we're going to discuss semantic technology and how it works. The business issue stems from the fact that there are billions of devices and systems connected to the internet, and they are generating copious amounts of data. Every day we produce 5 exabytes per day across a vast array of different databases and applications. Unfortunately, in most cases, a lot of this data cannot be shared across different applications, as most of the traditional programs are restricted by application design with limited ability to process external data. The solution is semantic computing. Semantic computing is an artificial intelligence technique that incorporates various technologies which gives computers the ability to recognize the context and derive the meaning from structured and semi-structured data. Syntactic interoperability and semantic interoperability are critical in the development of semantic computing technology. Syntactic interoperability is the ability of information systems to exchange data using a common data format. It is a key need for the Internet of Things in enabling the flow of data from connected devices using different data syntax and allowing the consolidation of that data into usable form. Semantic interoperability is the ability of these information systems to understand the information being exchanged. Semantic interoperability is key for data integration projects because different applications may use different data syntaxes, schemas, and formats to describe the semantically similar entities. The vision of a semantic web was promoted by the World Wide Web inventor Tim Berners-Lee and continues to be developed through the World Wide Web Consortium W3C, which Tim Berners-Lee leads now. The World Wide Web has transformed the Internet through common interoperability protocols such as Hypertext Transfer Protocol, Hypertext Markup Language, and Extensible Markup Language, which allows all the web content to be available and readable by humans and machines. Web 3 is the next iteration of the web that allows the ability to find and reuse data. It supports machine readable information and uses XML tagging. Resource Description Framework, RDF, is used for this data. Accordingly, Web 3 enables the interchange of data as well as documents. It also provides a common language for describing how data relates to real-world objects, thus allowing a person or a machine to commence with one database and then move through a continuum of external databases which are connected by being related in some way to the same subject. RDF is a W3C specification for a framework that is used in semantic technology to describe data in the form of subject, predicate, object expressions. These are known as triples. The data is generally retained in a triple store in any one of a number of formats. For example, Graham likes Gail would be a triple. A subject, Graham, a predicate, likes, and an object, Gail. A syntactically complete statement can be created into a single structure called an RDF triple. The simplicity of RDF data structure and the optional nature of schemas means that different sets of data can be combined and used together very easily. An ontology or dictionary provides the meaning and context of the information stored in the triple store. An ontology is a formal machine interpretable definition of concepts in an area of interest or domain. It describes the properties, features, and attributes of those concepts. It highlights any restrictions and describes the relationships between those concepts. An ontology is not hierarchical, and there is no concept of parent or child relationships. An ontology generally contains, among other elements, classes and concepts, relationships that are associations between these concepts, and attributes of the concepts, axioms, rules of the concepts, and characteristics of the relationships. Ontologies can be combined and extended, and can be totally customized to support a specific area of interest. For example, transport ontology can be pruned to only contain relevant details of shipping. An ontology can also contain metadata, which is annotations, data about the data, and it is information about the artifact itself as opposed to the domain. Details about classes, properties, and individuals themselves. Who authored something, when it was authored, statements about the class rather than instances of the class. If axioms are statements contained within the ontology, then these statements are meta statements or metadata for that ontology or entity. Any existing metadata can be used to create an ontology. For example, if there is a spreadsheet containing products, properties can be created from the column names and associated with the class product. Similar approaches can be used to generate ontologies from schemas in relational databases and XML. Other semantic web standards include the Web Ontology Language called OWL, which is a logic-based language designed to show the data schema and represent rich and complex knowledge about hierarchies of data and the relations between that data. OWL is used by applications that process semantic data and build on RDFS and knowledge representation technology to make more sophisticated modeling statements. OWL documents, known as ontologies, can be published in the World Wide Web and may refer to or be referred from other OWL ontologies. OWL is part of the W3C Semantic Web technology stack, which also includes RDFS, RDF, Sparkle, etc. Sparkle Protocol and RDF Query Language is a semantic query language for databases, able to retrieve and manipulate data stored in RDF. It is also a W3C standard and is recognized as one of the key technologies of the semantic web. Sparkle also allows a query to consist of triple patterns, conjunctions, disjunctions, and optional patterns. The advantages of semantic technology include the developers model semantics as RDF and OWL ontologies, and these are used to create structured content that describes the classes and relationships defined in the ontologies. Developers can use these ontologies to drive creation of mapping among existing data sets. Developers could use natural language processing and pattern recognition tools to extract the semantics from unstructured data sources. The extracted entities and relationships are used to create RDF and OWL ontologies. Other advantages include finding more relevant and useful information by searching disparate sources, federated search, and the ability to automatically refine these searches, faceted search, a better understanding by utilizing the relationships between concepts to predict and interpret change, building more transparent systems and communication based on common meanings and mutual understanding of the key concepts and relationships. It also increases the effectiveness with the use of a flexible solution framework and data sources, enabling users to change information systems more quickly and easily. And finally, the advantages include providing a more perceptive, intelligent, and collaborative approach, as users can now ask and have answered questions they couldn't ask before. There are three logical paths to follow in the evolution of semantic technology. Semantic software companies can continue to develop and refine their tools under the W3C developed semantic standards to produce commercially ready independent semantic platforms. The second option could include where vendors developing specialist artificial intelligence platforms and tools can collaborate to develop hybrid AI solutions which could contain semantic solutions, machine learning, and natural language processing. These will then solve problems involving structured and unstructured information where semantic computing enables the computer to apply context and meaning from the information with minimal human interaction. The NLP component is focused on enabling the computer to process natural language in text or in speech and focuses on unstructured information. And the machine learning deploys algorithms to detect patterns in the data and make predictions based on that data. The third option could involve vendors with a focus on business applications, analytics, business intelligence, data management systems, master data management solutions, where they all benefit from the ability to harmonize divergent ontologies across heterogeneous environments. Their challenge, therefore, is to integrate the required ontologies, inference engines, and RDF triple stores and other semantic components and interfaces into their own solutions to address their business requirements, which involves artificial intelligence overlaid in their business applications.